Alright, hello and welcome to another MATHCOUNTS problem tutorial. So today we will be looking at problem number 29 in the 2011 chapter sprint. So let's look at our question. Fido's leash is tied to a stake at the center of his yard, which is in the shape of a regular hexagon. His leash is exactly long enough to reach the midpoint of each side of his yard. If the fraction of the area of Fido's yard that he is able to reach while on his leash is expressed in the simplest radical form as root a over b times pi, what is the value of the product AB? Alright. So I have drawing tools. This is amazing. So his yard is a hexagon. So this is his yard, and the amount of space and the areas he can reach will be in the shape of a circle, because by definition a circle is the set of points that are a certain distance away from a certain point. So if I draw a circle like this, it doesn't exactly fit, but it's okay. These drawing tools are not that good. All right, so we have our hexagon, and now we have a circle, and the circle touches each point of this yard, each midpoint. The drawing is not great, but I think you can see. So let's figure this out. So let's say that this circle has radius r. So now what we can do is draw a line from the center to one of the vertices. Now, if you'll notice that I think I've done a video on this before, but like each angle of a regular hexagon is 120 degrees. And then this splits it in half, so it's 60 degrees. And because this is 90, now we have a 30, 60, 90 triangle, which, if you don't know, has a specific ratio of its sides, which is 1, root 3, 2. So what we're interested in is this side right here, which is 2 over root 3 times our r. So next what we can do is split this hexagon into 6 equilateral triangles. This is kind of a tough process, so you might need some practice with like hexagons. So if you'll notice that this length we just got is the side length of each of these equilateral triangles. So the area of an equilateral triangle, there is a formula for this. It is s squared root 3 over 4, where s is the side length. So we can plug in our value of the side length, which is 2 over root 3r squared times root 3 over 4, which means our area is 4 over 3r squared times root 3 over 4, which if you simplify gives you r squared root 3 over 3. And of course we have 6 triangles, so this will be multiplied by 6 to give the hexagon's area as r squared times 2 root 3. Now we want the ratio of the area he can reach to the total area. So this is the total area. Now the area he can reach will be the area of this circle, which is just pi r squared. So that means that our ratio, so if I go over here, is pi r squared over r squared 2 root 3. So we cancel the r squareds, which leaves us with pi over 2 root 3. However, this is not an acceptable answer. You're not allowed to have any square roots in the bottom. So what we end up seeing, so what we can do is we can multiply this by root 3 over root 3, which will, number one, get rid of this square root, but also it won't change the actual value, because root 3 over root 3 is just 1, and multiplying by 1 gives you the same thing, which leaves us with pi times root 3 over 6. So they wanted an answer in the form of root a over b times pi, so which means that our a is 3 and our b is 6, and of course we wanted the product ab, which means that our final answer is 18. Alright, let's do a second practice problem. Okay, so forget the dog for now. So now let's say that we just have a circle, and now it's the hexagon inside. So last time it was the circle inside the hexagon, now we have a hexagon inside a circle. So what is the ratio? Okay, pretend that this is a regular hexagon. What is the ratio of the hexagon's area to the circle's area? I'll give you a few seconds. You may need to pause the video here. So our final answer ends up being 3 root 3 over 2 pi. If you don't know how I got this, you can rewind the video to see how I did the first problem, or keep watching to see how I explain this one. So once again, we can say that the circle's radius is r. So again, we can split this hexagon into 6 equilateral triangles. We use our formula. Each triangle has area r squared root 3 over 4. So again, there are 6 triangles. So our total area of the hexagon is 3 root 3 r squared over 2. So now we want to put this over the area of the circle, which is, again, pi r squared. So we can cancel the r squareds and simplify this ratio, which gives us 3 root 3 over 2 pi. Alright, now I'm going to give you a third practice problem. But this time, I'm not going to show you the answer or work it out in this video. What I want you to do is work it out by yourself and then leave your answer in the comment section so that I can see it later. So now let's say that once again we have our big circle, and this time let's say that we put an octagon inside it. So what is the ratio of the area of the octagon to the circle? Alright, thank you for watching. I hope you learned something about hexagons and circles in this video. Please like the video, subscribe to the channel, and I will see you later. Bye!